We now discuss the solution of a problem that appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The problem is from the section Statistics and Probability, and the problem is on the probability. The given problem is: in an examination, there are 10 true or false questions. Out of 10, a student can guess the answers of 4 questions correctly with the probability 3 by 4, and the remaining 6 questions correctly with probability 1 by 4. If the probability that the student guesses the answers of exactly 8 questions correctly out of 10 questions is 27k by 4 to the power of 10, then k is equal to. So there is an examination consisting of 10 true or false questions. Out of these 10 questions, a student can guess the answers of 4 questions correctly with a probability 3 by 4, and he can guess the answers of the remaining 6 questions correctly with the probability 1 by 4. It is given that the probability the student guesses the answers of exactly 8 questions correctly out of the given 10 questions is 27k by 4 to the power of 10. Then find the value of k. We will now discuss the solution of the problem in detail. We have 10 true or false questions. Given the probability of guessing the answers of 4 questions correctly is 3 by 4. Let capital A suffix r be the event of guessing the answers of r questions correctly with the probability 3 by 4. Then the probability of A suffix r is 4cr into 3 by 4 to the power of r into 1 minus 1 by 4, 1 minus 3 by 4 to the power of 4 minus r, that is 1 by 4 to the power of 4 minus r. So the probability of AR is 4CR into 3 by 4 to the power of r into 1 by 4 to the power of 4 minus r. And I may say, if the question is with the probability 3 by 4, then I'll say it is A type question, capital A type question. And given the probability of guessing the answers of 6 questions correctly is 1 by 4, this is called B type question. Let B suffix S be the event of guessing the answers of S questions correctly with the probability 1 by 4. Then the probability of BS is 6CS into 1 by 4 to the power of S, that is for correct. For wrong, that is 1 minus 1 by 4 to the power of 6 minus S, that is 3 by 4 to the power of 6 minus S. Probability of B suffix S is 6CS into 1 by 4 to the power of S into 3 by 4 to the power of 6 minus S. And if the student is guessing the questions of this type, then I'll say this is of the B type. B type means the guessing correctly for with the probability 1 by 4. Now let E be the event of guessing answers of 8 questions correctly out of 10. So what are the possibilities? 4 questions of A type, that is with the with the probability 3 by 4 and 4 questions of B type. 4 plus 4, 8. That is one choice, one possibility. The next is 3 of the A type, that is 3 with the probability 3 by 4. The remaining 5 of the type B, that is with the probability 1 by 4. That is 4, 4, 3, 3 or 2, 6. 2, 6. That is 2 questions of type A, that is with the probability 3 by 4. 6 of B type, that is of the probability 1 by 4. So 2, 6. So what are the possibilities? 4, 4, 3, 5, 2, 6. These are the only 3 possibilities. Therefore, the event E is A4 intersection B4 and 4 and 4 and union 3 of A type and 5 of B type, that is A3 and B5 union A2 intersection B6. And this is the what we have. So we continue in the next slide. So we have the probability of A suffix R, probability of B suffix S, and E is the event of guessing the answers of 8 questions correctly out of 10. Then this event E is given by A4 intersection B4 union A3 intersection B5 union A2 intersection B6. Then let's take the probability. The probability of E is equal to the probability of the first A4 intersection B4 plus the probability of A3 intersection B5 plus the probability of A2 intersection B6. Let's call this as the equation 1. Why this is plus? The plus plus is coming because they are mutually exclusive. So now probability of A4 intersection B4 is probability of A4 multiplied by probability of B4 because the events are independent. That is equal to probability of A4 is, use the formula 4C4 3 by 4 to the power of 4 into 1 by 4 to the power of 4 minus 4, right, into B probability of B4, that is 6C4 into 1 by 4 to the power of 4 into 3 by 4 to the power of 6 minus 6 minus 6 minus 4. 6 minus 4. 6 minus 4 is 2. It's not 2, it is 6 minus 4. 6 minus 4. That is 3 by 4 to the power square. Now that is 4C4 is 1. 3 by 4 to the power of 4, correct, into 1 by 4 to the power of 4 minus 4 means 1 by 4 to the power of 0, 1, 1 into 6C4 is 6C2 is 15, 1 by 4 to the power of 4, right, into 3 by 4 to the power of 6 minus 4, and that is 3 by 4 to the power of 2. Further simplify, that will be equal to 15 into 3 by 4 to the power of 4 into 3 by 4 to the power of square, that is multiplication 3 by 4 to the power of 6 into 1 by 4 to the power of 4, correct. Now let's get into this next one, probability of A3 intersection B5, that is probability of A3 multiplied by probability of B5. For A3 we write 4C3 into 3 by 4 cube into 1 by 4 to the power of 4 minus 3, that is 1 by 4 to the power of 1. 6C5 into 1 by 4 to the power of 5 into 3 by 4 to the power of 6 minus 5, correct. That is equal to 4C3 is 4C1, that is 4 into 3 by 4 whole cube into 1 by 4, right, minus 6C5 means 6C1, that is 6 into 1 by 4 to the power of 5 into 3 by 4 into 3 by 4. 6 minus 5 is 1. So 6 fours are 24. 3 by 4 whole cube into 3 by 4. 3 by 4 to the power of 4. Agreed. Into 1 by 4 to the power of 6. Here it is 1, it is 5, it is 6. So probability, next probability of A2 intersection B6 is multiply that is probability of A2 multiplied by probability of B6, that is equal to 4C2. Agreed? Because 2, 3 by 4 whole square into 1 by 4 to the power of 4 minus 2 into B, probability of B6, 6C6 into 1 by 4 to the power of 6 into 3 by 4 to the power of 6 minus 6, that is 0. 3 by 4 to the power of 0 is 1. So now simplify. So 4C2 is 6 into 3 by 4 whole square into 1 by 4 square into 6C6 is 1. 1 by 4 to the power of 6. Multiplication. So you will get 6 into 3 by 4 whole square into 1 by 4 square into 1 by 4 to the power of 6 is 1 by 4 to the power of 8. So these are the things. Now we add them up and equate it to that given thing, that is 27k by 4 to the power of 10. So we continue in the next slide. So these are the things what we have done so far. Now probability of E is equal to this probability of A4 intersection B4, that is this one, plus probability of A3 intersection B5, that is this one, into probability of A2 intersection B6, that is this one. So these are the things what we have written here, and this is given to be equal to 27k by 4 to the power of 10. 4 to the power of 10. Now in this, so here 3 square and a 3 from 6 is coming, that is 3 cube you take out, and 3 cube you take common. Now 4 power 6, 4 power 4, 4 power 10, 4 power 4, 4 power 6, 4 power 10, 4 power 2, 4 power 8, in the denominator 4 power 10. So that is coming out throughout. So that is 3 cube by 4 to the power of 10 into 3 cube. If 3 cube has gone, 3 cube has gone, then it will be 3 cube and a 3 from here, 3 power 4 into 5 plus 3 square into 8 plus 2 is equal to 27k by 4 to the power of 10. In the denominator 4 to the power of 10, 4 to the power of 10 cancels. In the numerator 3 cube and 27 cancels, and you will get k is equal to 3 power 4 into 5, 81 into 5, 405, 3 square 9 into 8, 72 plus 2. So the total is 479. K is equal to 479. Thus we have found the value of k. So that is the discussion of the solution of the problem from the section statistics and probability, and the question is on the probability. And I am sure that you have understood the solution of the problem, and I wish you all the best. Thank you.